Hi everyone, I hope you're doing great. Exciting news, a new anomaly of interstellar object 3I Atlas. The mystery continues, and this one is quite baffling. So they have looked at, or we have to say, re-observed interstellar object 3I Atlas in December. SPHEREx has re-observed 3I Atlas post-perihelion. They have already looked at it pre-perihelion, and they have looked at it between December 8th and December 15th, and we've got the images now. And there is a new paper that just came out about that, and they have noticed that 3I Atlas is a much more active object compared to what they saw in August 2025, the pre-perihelion observations, right? Pre-perihelion, they thought they found evidence for development that 3I Atlas was changing into a cometary body, fully sublimating all its ices because of the sun's energy. But the new imaging spectral photometry, how this is called, is dominated by something else, guys. I will show it to you. It's very, very interesting. But do me a favor before we do this. Give this video a like and an early hype. It helps my channel, doesn't cost you a thing. Okay, let's start. So now we finally have the first post-perihelion infrared images that allow us to understand what actually happened after 3I Atlas passed its closest point to the sun. And these images, as I said, they reveal something that, are we surprised, does not behave the way a normal comet should. What we're looking at, and I'll explain the graphic in more detail in a second. What we're looking at comes from NASA's SPHEREx observations taken after perihelion. These images do not just show us like a small fuzzy dot. There's way more. They show a massive cloud of gas and dust that is extending roughly about 300,000 kilometers, 250,000 miles in each direction. And that is almost the distance from the Earth to the moon. It's far. And the brightest distribution, and that's also interesting, is not round, it's asymmetric. It means that one side is longer and brighter than the other side. And the most important detail here is this. The brightest and the most extended part of that dust plume is oriented towards the sun, the famous antitail, towards the sun, not away from it. So normally comet tails point away from the sun. We know that. 3I Atlas, huge anomaly. Why do they point away from the sun? Well, this happens because sunlight and solar winds are pushing gas and tiny dust particles that are there outwards, away from the sun. So if you see a tail pointing towards the sun, it's already a red flag. If it's not an optical illusion, right? It's a red flag then that something unusual is happening. And is this anomaly number 19 or something like this that we have discovered today? So in the new image, the contour lines are drawn on top of the brightness map. So that's what they did to help us see better what's going on there. And these contours represent the signal strength. So a higher contour means stronger emission compared to the background noise that is always visible in these images. So the strongest contours are concentrated on the sunward side, on the antitail. That reinforces that this is not an optical illusion or an artifact. It is real physical asymmetry. Boof! But now let's talk about what that plume is made of. We're working ourselves towards that anomaly. So the spectral data, they show clear signatures of several molecules. There is emission from CN, which is cyanide gas. If you sound surprised, check out my video that I made about this. I put the playlist for 3i Atlas in the end screen for you guys. There's cyanide on 3i Atlas. Made a video about it. So this thing could either kill us or seed something on Earth, right? That was the motto of this video. There's strong water emission at wavelengths around 2.7 to 2.8 microns. There are organic molecules indicated by carbon-hydrogen bonds between 3.2 and 3.6 microns. There is carbon dioxide emission around 4.2 to 4.3 microns. And there is carbon monoxide emission near 4.7 and 4.8 microns. So each of these molecules that we just talked about, and that's the important part, it emits light at a very specific infrared wavelength when it's energized by sunlight. So this is how scientists can identify chemical composition from a distance, because you might ask, well, how do they know what this thing consists of, right? So we're not guessing. We are reading a molecular fingerprint. This is how we can call it. So what really stands out is that water emission is significantly stronger after perihelion than before. That means the object became more active after it passed its closest point to the sun, not less. And that alone, guys, is already highly unusual. Why is the question? But the real anomaly appears when we look at the reflectance spectrum of the dust that is around 3i Atlas. Reflectance, you might ask, okay, explain. Okay, here's the explanation. Reflectance tells us how light is scattered by solid particles. So if very small dust grains are present, they scatter short wavelength of light more efficiently. This effect is called the Rayleigh scattering. It's basically the same reason why Earth looks blue, right? That's just on a side note. So in these data, Rayleigh scattering is absent. It's not there. So what does that mean? In conclusion, it must mean that tiny particles are missing. How can that be? So, because if there were these tiny particles, these tiny grains, the solar radiation pressure would push them strongly away from the sun, and it would form a classic dust tail, classic comet dust tail, pointing away from the sun, pointing in the anti-solar direction. But it does not. That's not what we see. Instead, and that's baffling, the reflectance spectrum indicates that the dust consists primarily of large grains or chunks. We've talked about that before. So large particles do not respond strongly to solar radiation pressure. They move slowly and they stay closer to the source. So this explains why the plume is broad, massive, and sunward biased instead of forming a narrow tail. But this creates a problem. To produce the observed brightness that we see in 3i Atlas, if 3i Atlas is using large grains alone, the total dust mass must be extremely high. That's the key takeaway that we have. The total dust mass must be extremely high to produce that massive brightness. It must be much higher than expected from standard comet models, and that means, in other words, a huge amount of material must be coming off interstellar object 3i Atlas, must be coming off, and it must be coming off in the form of relatively large pieces, not like fine powder. Poof! That is the core anomaly. How can this happen? Standard comet physics predict that activity near the sun should produce abundant small grains, strong radiation pressure effects, and a tail pointing away from the sun. What we see here absolutely contradicts that prediction. The shape of the plume that we see in the new images, the absence of the small grains, the dominance of large dust, and the post-perihelion increase in water emission, together with all the other stuff, indicate that this object does not follow the usual cometary behavior that we're familiar with from the solar system. So what is very important, none of this requires any speculation. These conclusions follow directly from these infrared images and spectra. It's not just we think, we know. Of course, also, the new data do not specifically imply anything artificial. That doesn't mean it's a spacecraft or anything. They do not require extremely exotic explanations, but they do show, if we just want to like lock in the status quo in a description without judging what it really is, they do show that interstellar objects that are not from our solar system, this is just the third one that we've ever seen, they behave in ways that are fundamentally different from native solar system comets. That we can clearly say. That's why the term anomaly here is very, very appropriate. The object for us, it's mysterious. In a sensational way, it is, because we find it like, wow. But it is especially mysterious because it violates expectations that are derived from decades of observing ordinary comets. Scientists thought they know it all. They obviously don't. And what Harvard professor Avi Loeb is criticizing is that so many of them don't seem to be like interested in getting further ahead. They're like, it's a natural comet, check mark, over and out. Well, then explain all that, right? NASA, explain. So the SPHEREx data, what can we say in short? It shows a massive sunward oriented plume dominated by large dust grains, unusually strong post-perihelion water emission, and a lack of fine particles. Together, these features absolutely challenge our standard models, and I think in the long run, or they should right now already force us to rethink how material is released from interstellar bodies when they encounter a star like our sun. It seems it's completely different. And that's why these observations are so important. They're not just images, right? They're constraints on physics. They tell us that what we thought was a normal comet behavior may not be normal for objects that have not formed here in our solar system. So when we look closely at the images, because this is where really we can see the anomaly, it becomes visible. When you're looking at the first image here, this large infrared brightness map, this is basically not a photograph in visible light. It's a map that shows us how much infrared radiation is coming from gas and dust around the object. Brighter areas mean more emission, darker areas mean less. So the scale here is enormous. It's absolutely enormous. The full frame, as I said, covers 300,000 kilometers across. That means this cloud is not a small tail. It's a massive extended structure. At the center of the image we see is the brightest point. That marks the location of the nucleus. And then around it, you see a broad, uneven glow. The glow is not symmetric, it is stretched and it's elongated. So now notice the direction of the elongation, right? It's towards the sun. The brightest and longest part of the cloud extends towards the sun. And when you see that picture, that's what's immediately unusual, right? And then overlaid on the image are the contour lines. These work like basically elevation lines on a topographic map. That's what we can, or what you can compare it with. Like each contour marks a level. So in other words, If we look at the top images, here they show us what surrounds interstellar object 3I Atlas when we look at it in infrared light, not normal visible light, right? Infrared light lets us see heat and gases and not just only the reflected sunlight. And as I said in the beginning, these images were taken over several days from December 8th to 15th. We have to do that because comets sometimes change behavior in a way that could mislead us. So we need a little bit of a longer time frame. They combine now light from a wider range of infrared colors from 0.75 to 5 microns. Different gases, we know that they glow at different infrared colors. So this range lets scientists see many materials at once. Isn't physics amazing? And each image is huge in scale, as you can imagine, right? From left to right and from top to bottom, each image covers this space of 300,000 kilometers. Bright lines on the image, they're the brightness contours. As I said, they're drawn like contour lines on a map. Each line marks areas that are 5 times, 20 times, and 50 times brighter than the background noise. And this helps to tell us which features are real and strong and which are just like faint background signals that have nothing to do with the object. And then we have this color bar on this image that shows the brightness in a unit called megajansky per steradian. Sounds complicated, but you do not have to remember that name. Just forget about it. All it means, brighter colors equal more infrared emission. Boof. That easy it is. And the black arrows that are labeled north and east tell you how the image is oriented in space, basically like a compass, so that we know which direction is which. But the other arrows, they are extremely important. The red arrows shows the direction directly away from the sun, and the blue dashed arrow shows the direction opposite to interstellar atlas motion. So when the scientists now look at this dust and organic material on large scale, the cloud is pear-shaped, not round, right? Like that. And the long stretched part of that pear shape points towards the sun. That's the antitail. Well, the other gas clouds that we see around the object, that's actually 6 of them, they are nearly round. Only the dust and organic materials show this strange sunward stretching. And if we look at the middle panel of this graph, it shows us how bright the different gases are at a different infrared color scale. Each dot is a measurement. The color of the dot tells you when the measurement was taken. The color bar on the right shows the dates. All measurements have been corrected, so distance does not affect brightness. In other words, the scientists that looked at it have adjusted the data, so it is as if the object, Earth and the sun, were all exactly 1 Earth-Sun distance apart. This makes fair comparisons possible. That's what we need as a basis. So it gives us how these different gases glow at specific infrared colors. So these are marked on the graph. We have the CN, the cyanide gas, around 0.93 microns. We have the water vapor, 2.7, 2.8, organic molecules between 3.2 and 3.6, carbon dioxide around 4.2 and 4.3, carbon monoxide 4.7 to 4.8, and each gas has its own colored label, so scientists can see which bumps in the graph belong to which gas. So this graph tells us in simple terms what gases are coming off the object and how strong are these emissions. And then if we look at the bottom panel, we can basically see what the dust is actually doing. It shows something called, I mentioned it earlier, the reflectance spectrum. Sounds complicated, but it just means how does the dust reflect sunlight compared to the sun itself. So this tells us what kind of dust particles are present. Sunlight, we know, is bouncing off of solid particles. Heat is emitted by warm dust. But here's the crucial part for interstellar object 3I Atlas. We do not have these tiny grains present. We do not have particles that are smaller than a micron, because then they would scatter blue light very strongly. This is the Rayleigh scattering, and that's again why the Earth looks blue. But 3I Atlas, that blue enhancing signature is absolutely missing. That means tiny dust particles are not present in numbers. Put all these panels together, they tell one clear story. The dust cloud is huge and oddly shaped, dust stretching towards the sun instead of away. Gas clouds are mostly round and normal. Dust is made of large grains, not fine powder. Usual comet tail mechanism is missing, and that's why we can call this an anomaly. Harvard Professor Avi Loeb was hoping that these images would explain the anomalies that we're seeing, but actually these ones, they do not. They have created another anomaly, believe it or not. And guys, check my other videos. January 19th is an important day. I explained it. I made a video about it. Check it out in the end screen. There's so much going on everywhere, from earthquakes, volcanoes. Just check a few here in the end screen. I have, well, put a few there that you might not have seen. If you have, go to my channel start page, click on videos, click on recent, then you see everything that I have released. Thanks for watching, guys. Please subscribe if you're new here. We are a great group. Hope to see you again in a second if you click one of these videos. Bye bye, guys.